All right, hello everyone. Dear authors and invited guests, welcome to technical session 12A. My name is Dhimahi and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information and Communication Technology for Intelligent Systems, Bangkok, Thailand. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, and the virtual event is being held through Zoom from 9 to 11th April 2026. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Now, before we start with the presentations, I would like to introduce you all to the chair of the session. We have with us Dr. Chandrakant Dilip Kokane. Dr. Chandrakant is an associate professor at the Vishwakarma Institute of Technology in Pune with 11 years of professional experience. His research interest primarily focuses on machine learning and natural language processing with active involvement in teaching and research. A warm welcome to you, sir, and I request you to share any introductory remark to the presenters today.
Yes, thank you, ma'am. Thank you. Yeah, we can start with the presentations, ma'am.
Okay. So starting up, I would like to call Selvamani K to present their study on a chaos-based permutation diffusion framework for secure and efficient digital image encryption. Selvamani K, sir, are you present? Or any of the co-authors of this paper? Samar Moakit. Samar, ma'am?
Yes, can you hear me?
Yes, ma'am. Please present your paper on a hybrid semantic linguistic framework for clinical detection of drug-drug interactions and contraindictions.
Okay. Thank you very much, esteemed moderator, esteemed chair, and audience. Today, my presentation will be on, let me share it first, how to share. Okay, let me share it. Okay. Can you see it?
Yes, ma'am.
Okay, let me put it. Okay, wait 1 minute. Okay.
Yes, ma'am.
Okay, thank you, everybody. Today, I will present my work, a hybrid semantic linguistics framework for clinical detection of drug interaction and contradiction. This research focuses on improving medication safety, especially for patients who take multiple drugs. So the idea is to enable those who take multiple drugs to be able to alert them if there are any complications. So the main idea is to combine text understanding with semantic reasoning to detect harmful drug interaction and contradictions in a more explainable way. In this presentation, I will briefly explain the problem, the proposed method, and the main results. Okay, let me go to the second slide. Okay. Now here in my research objectives, okay, first, the goal is to detect drug-drug interaction and contraindications. This means identifying first the goal for a drug combination that may be harmful or drugs that may not be suitable for patients because of age, disease, or other conditions. Okay. Second, the framework uses both structured clinical data and free text clinical notes. This is important because useful medical information may exist in both forms. It could be as a text, it could be structured clinical data. Third, the system generates explainable and context-aware alerts, so it is not only detecting risk, but also gives a clearer reason for the alert. Finally, the aim is to support safer decision-making, especially in polypharmacy cases where the patient is taking 5 or more medications. So this is very important study for those who are taking multiple medication to alert them or to alert the doctors of any contraindication. Why is this study important? Okay, first of all, polypharmacy means that the patient is taking many medication, and this increases the risk of adverse drug events. The risk becomes even higher in older adults, especially those with multiple chronic diseases. Another issue is that many current clinical decision support systems still rely on fixed rule sets. These systems are useful, but they miss many important contexts, such as free text clinical notes. Also, a lot of useful information is written in unstructured, that's why I said clinical note, which is often not fully used. So this study is important because it tries to address these gaps and improve medication safety in a more intelligent and explainable way. So this study mixes the structured clinical data with unstructured notes and free text. Okay, now let's move to the next slide. Okay, this explains what is our methodology or what our framework. First of all, we use Python code during all the implementation phases. We use, in the first stage, the researchers created 1,000 synthetic patient profiles. As you know, data about patients is very private and confidential, so we're not able to get really actual data. So we relied on synthetic data to get the result. These profiles included diagnosis, medication, clinical notes, standard medical vocabulary such as SNOMED, CT, and RX norm were used to organize these data. In the second stage, okay, BioBERT was used to process the clinical text and extract important information such as drugs, medical condition, and the relations between them. Okay. Now, in the third stage, the extracted information was converted into RDF triples and stored in a knowledgeable graphs using Apache, Gina, Fusik. This helped organize the data in a structured semantic forms. Finally, ontology-based reasoning and risk scoring were applied in this stage. Medical rules were used to generate alerts and calculate the level of the risk for each patient. So we created this table in order to show the steps that we have used and what kind of system we have used. Okay. Now, in this slide, we found that we explain what are the really implications of our study. This slide explains the practical value of our proposed framework. For healthcare organization, the methods can support safer medication review and improve clinical decision support workflow. For clinicians, it provides explainable alerts for drug-drug interaction and contraindications by using both structured record and unstructured records from free text notes. For patients, this may help reduce preventable medication-related harm, especially in polypharmacy cases. Finally, for digital health systems, the framework supports more interoperable and knowledgeable-driven medication safety tools. Now, of course, our study is not complete, okay? We still need to improve it. So here we suggest what kind of future work would improve our study and provide better results. So first of all, our framework was evaluating using synthetic patient profile, not real hospital data. This means the results are promising, but they are still need to be validated by real data. So healthcare organization, they can use our framework on real patient data and get really good results related to the risk of taking more than multiple medications. Second, our current framework does not yet consider temporal or dosage-dependent medication effect. In other words, it does not fully model how drug risk may change over time or with different dosage. So this could be another, let's say, future studies that can improve on our current study. Another limitation is scalability, because larger and more complicated clinical knowledge graphs may be difficult to manage. For the future work, that's why we suggest that researcher plan, and what we are planning, inshallah, to validate the framework on real-world data integrated into FHRI-based system and compare it with existing clinical decision support platforms. In conclusion, the proposed framework showed that combining biomedical text understanding with ontology-based semantic reasoning can improve medication safety detection. The system was able to detect both common drug interaction and more complex contraindication that depend on the patient's condition. The results also showed that alert rates were higher in older adults and in patients taking multiple medications. Overall, this framework is a promising step toward more explainable and intelligent clinical decision support. I thank you all for listening, and I hope you have any questions that I can answer them. Thank you very much.
Chandrakant sir, any questions for ma'am?
Thank you, ma'am. Nice presentation.
All right, thank you, ma'am.
Thank you. Okay, I will stop sharing. Okay. Thank you very much.
Now, next I would call Selvamani K to present his study on a quantum-resistant security framework for real-time financial transaction systems. Selvamani or any of the co-authors? Abhay Saxena. Abhay sir, are you present?
Yes, ma'am. Yes, ma'am.
Yes, sir. Please present your study on adverse rainy condition classification using customized lightweight CNN models for UAVs.
Ma'am, my slides are visible.
Yes, sir.
Yeah. So good afternoon, everyone. Today I will present our work on the classify adverse rainy condition using custom lightweight CNN for UAVs. I am myself Abhay Saxena. I am from IIT Bhubaneswar. The basic agenda of the today's paper is like this one, and the challenges of the UAV in range. Actually, the autonomous UAV rely on the camera for the navigation, but rain interferes with the perception. Heavy rains lower the image quality and leads to the navigation error. So we are using a deep network to detect the rain condition. So they are actually the existed pre-trained models are very too big in the size. So the main goal is to develop a lightweight model efficiently model to classify different rate condition in the real time on resource constraints UAV. This is my literature review. So according to literature review, I found that like the for the real time UAV deployment, the lightweight model is necessary. So I take a public available data set. In the public available data set, they set up an experimental condition. The author collects raw color images to construct a data set representing the different rain condition. That is clear, slanting heavy, low rain condition, vertical heavy, vertical medium, low rain condition. The experiments were conducted in the controlled indoor lab and simulated rain condition by the sprayer. Actually, the author set a sprayer at a particular angle. So, like for the slanting, it's at a 30-degree angle. Uses the UAV mounted Intel RealSense P431i RGB camera. So the total data which is publicly available for the training efficiency. We subsample 15,000 images per class for the balancing the folder. So there are 7 classes, so there are 1,05,000 images in which we train 80%, validate 10%, and test 10%. The proposed method, actually my model is inspired by the DenseNet complex CNN. Basically, it connected like every layer is connected to the previous layer. So it used dense connectivity to use the feature and keeps the parameter count low. Core element, I use dense blocks, transactions layer, initial layer, global edge pooling plus fully connected output for the 7 classes. This is my like model architecture. In the results, very few layers and the parameters, approximately 22,800 parameters with when k is equal to 8. I will define what is k. Actually, like k is considered as a growth rate, which is hyperparameter tested, and I perform an ablation study on my model with a parameter with a growth rate of 4, 8, and 12, with a base size of 32, 64, and 128. So I found that like with k is equal to 8 and the with best number is equal to 64 give the best accuracy. My observation is like a k is equal to 4 when growth is 4, the that is very small unfit condition and the accuracy is 81.2%, but the parameter is 6.3k. When the k is equal to 12, the last condition higher frequency or higher accuracy, 96.6 accuracy, but the very large model, the parameter is increased by like a 49,000, 50,000 parameters. And when the k is equal to 8, so optimal trade-off, 95.93 accuracy with a 22,807 parameter, or the model size is 89 kb. I further analysis to check the robustness at the k is equal to 8. I tested my model on the different seeds, random seeds. So I get these accuracies, which then I mean and validate or standard deviate the accuracy. The on an average, I get the accuracy of 95.72 percentage. This is my graphs. So you can see that the both training and validation accuracy quick rise and model converges rapidly with no overfitting. Similarly, the loss drops sharply in early blocks and stabilize at a low values. This is a confusion matrix. Each and every classes mainly above the 95%. The clear image get the 99% accuracy. The main confusion between low and the medium range because range condition is little bit similar. That's why the model distinctly separates slanting and vertical lean. Stronger, I can say that the strong diagonal blocks in the confusion matrix. Then, yeah, I also benchmark with a pre-trained model. So I compare my model with the dense net, efficient net, inspection ResNet, inspection V3, mobile net, ResNet, VGG expansion. All the pre-trained models, none of one is more than 95%, but my custom model get the accuracy more than 95%. And I also calculate the inference time because we are dealing in the real-time UAV deployment. So I calculated the inference time on the Jetson Nano because of the lightweight. I get just the 32 milliseconds for the inference time for testing of one images. Meanwhile, you can see that like for the inspection reset, instance time is very high. I conclude in that manner the present custom lightweight CNN for classify the end condition is successfully and achieved the 95.93% test accuracy on the 7 weather classes with the only parameter 22.8k parameters. Model outperforming large network in the accuracy, inference time in the memory footprint, demonstrate feasible of the real-time weather condition and integrate. I will integrate this classifier into the UV navigation system to automatic adapt flight behavior in the rain. Thank you. This is my differences.
Chandrakant sir, any
Uh,
questions?
Sir, what is motivation behind this topic?
So actually, like for the real-time UAV deployment, because of the UAVs are on the basically the edge devices, they have memory less. There is a shortage of the memory. So if it is better to run the lightweight model to get the better inference time, that's like
Okay, so only you are proposing a lightweight machine learning model for
yeah. I
edge
am proposing
computing
the
devices.
lightweight. Sorry, sir.
You are proposing lightweight machine learning model.
Yes, yes, sir. So,
So how it is different than traditional machine learning models?
so actually, see, I compare all the parameters with the pre-trained model. My parameters or my model size is just 89 MBs or 89 KBs, and all the pre-trained models only all are have a very large or bulky. Suppose I can say that the DenseNet 201 of 150, DenseNet 201 222 MBs. So obviously the inference time will be increased for the pre-trained model.
Okay, sir. Thank you. Over to you, coordinators.
Yes, thank you very much.
Thank you, ma'am.
Next, I would call Arjun Verma to present the study on bonding of material and electrical properties of EVA shoes under various physical and manufacturing conditions. Arjun Verma or any co-author of this paper? Nasika Ijaz. Nasika ma'am,
Yes,
please
yes,
present a
I'm
study
present.
on development of a context-based prompt generation framework to enhance model-driven engineering using retrieval augmented generation with large language models.
Yes, just let me share my slides. Okay, is it visible?
We can see your Zoom screen, not your PPT, ma'am.
Okay, let me try and fix that. Okay, is it now visible?
Yes, ma'am.
Okay, thank you. Greetings, I am Nasika Ijaz and I will be presenting my research on the behalf of my co-authors as well. The research topic is development of a context-based prompt generation framework to enhance model-driven engineering using retrieval augmented generation with large language models. Current models use LLM's approach with prompt engineering from object-oriented model creation. In contrast to the traditional model generation methods that existed in model engineering, the process is automated using LLMs and PE, and it has shown potential improvement in the performance. The corrective analysis in recent studies shows that LLMs are competent in adhering to the constraints, but they face challenges in modeling complex relationships. The proposed framework uses Llama GPT-4 PlantUML to develop a framework that generates context-based prompts for models. The current dataset that was used in the study was the prototype was tested on synthetic UML cases generated through Code Llama and PlantUML. Since the goal was architectural feasibility, we validated through coverage-based metrics instead of data-based training. The manual validation based on correctness of classes, attributes, and relationships was confirmed, and the future potential for this framework includes the integration with benchmark datasets, while plan to measure precision and recall F1 on the generated UML structures. Why this specific problem? Because models generated using RAG, LLMs, and MDE lack contextual correctness due to the vague input, creating the need for context-based model generation framework. As you can see, there are previous existing models that address this problem. However, some use RAG and LLMs, but they do not focus on model generation. Others use GPT, but they lack a retrieval augmented context-rich approach, and some rely on prompt engineering but lack context. To address the contextual part of this problem, the following framework was proposed. The research gap that was identified was currently direct application of LLMs to MDE framework was impractical because they were not very much compatible with each other. Both were inclined to make errors in complex tasks, making their direct application unfeasible. So the purpose was the automation in MDE using LLMs and RAG, resulting in improved accuracy, but it used to lack contextual correctness. So the research question that was proposed was how can a RAG framework combine LLMs while improving the accuracy and automation in MDE? Focusing on this research question, the three objectives were defined. The first one, improve transparency by providing UML description that explains model's behavior. Second was to improve user understandability of the model and enable users to trace the outputs from the input. And the third was to improve contextual correctness of generated models through generated prompts. This is the proposed methodology that was used for the framework. The proposed framework integrates RAG with LLMs to automate UML model creation. It starts with a user query, which is used to trigger this sentence transformer embedding. From there, our framework used FIS to retrieve the context of the model, from which prompt construction, context plus query, was constructed, which was given to the LLM generation, Code Llama and GPT-4. Then it was used to generate the code and the UML description, and in the end, the UML model itself was created. This pipeline was used to ensure that context-aware and accurate models are generated. This was the proposed architecture pipeline. The sentence transformer created text embeddings using LangChain. The FIS was implied for similarity search at speed. Code Llama was used to facilitate both code and text outputs. The Hugging Face transformer facilitated loading pre-trained models. Every part of this framework was used to aid in the end result of creating an accurate UML model with description. And for graphical description, plant UML was employed. The output was as follows. The image was a bit large, so I had to cut down to 2. As you can see, this was created by our model. The classes were expected from the query were 4, and they were generated 4. Attributes were expected 20, however, created were only 18. The relationships expected were 7, and they were generated 6. The framework generated UML class diagrams, which were validated for structure completeness. The coverage analysis showed that class recognition was 100%, while attribute accuracy was 90% and relationship identification was 85%, demonstrating that a context-rich generation, even without dataset fine-tuning, was possible and had reliable results. The results and analysis. To evaluate the performance of each model, the presence of classes, attributes, methods, relationship was identified in the generated UML description in comparison with the original UML code given as the input. The percentage of correctly identified entity with respect to total entities was calculated to ensure the coverage of each category. Coverage describes the extent to which a model can identify elements from provided code to when the description was produced. The comparison was done with 2 different systems. Code Llama system was the proposed model. DeepSeek and ChatGPT were given the same UML code as input. They were given the identical prompts to be able to generate the same results. As you can see in class coverage, all performed exactly the same, but in method coverage, ChatGPT was not able to perform as it had skipped a few methods while creating the description. Moving on to further analysis. There was method coverage, which indicated the percentage of methods in the code that were identified correctly in the output. Relationship coverage was the extent to which a model recognized the relationships. If a model identified all original methods, it was 100%. Recall, if it did not, it had a lower recall. In methods of table 3, metrics of method coverage, you can see that ChatGPT was got a recall of 80.9. It was because it was unable to identify all methods correctly. In table 2, relationship coverage, you can see DeepSeek has a F1 score of 94.7. It was because the input had 9 relationships, while DeepSeek had identified 10. It had identified an additional relationship which does not exist there, due to which its precision went down to 90%. The comparison. We compared our proposed model with ChatGPT and DeepSeek to assess how open weight and proprietary LLMs handle context-rich model generation tasks. As you can see, ChatGPT had a great understanding of context handling, but its UML structure was moderate. The DeepSeek had an average context handling, but its generation speed was fast. Our method had an even performance of being strong in context handling and UML structure. However, the speed was a little low. The research question. The research question aimed at the working of LLM and RAGs together. RAG introduced context retrieval, it improved the prompt specificity. LLM automated the UML text and code generation. Combine these together, the framework enhanced accuracy, which was contextual correctness, and automation was prompt to model flow. The result was improved understanding and less ambiguity in the generated UML model. The conclusion and future work. Model generation framework provides contextually accurate UML description to enable user to better understand the generated UML diagram. The automated generation process saves time and increases user understandability. However, the framework can be used to support advanced UML elements. It requires the use of diverse datasets that can be used to train the model to increase generalizability. As mentioned before, our model was trained on synthetic UML, so the future work remains of checking it or training it on diverse datasets that are real-world models. And another is to enhance model tuning to raise the precision of created models. Thank you so much for your time. If you have any questions.
Okay, so ma'am, I have one question. So you are just
Yes,
talking
please.
about LLM, large language model.
Yes,
Okay.
yes.
So do you found any another option for LLM or to LLM? So instead of LLM, we can go with another classifier.
Yes, for my project, since it was architectural feasibility was the actual aim, Code Llama 7B construct was the most lightweight from the available options. ChatGPT and DeepSeek are also LLMs, but as you can see, without RAG, they were unable to 100% identify the relationships. So there are other options as well, yes, and they could be included in the future work. But since my was architectural feasibility, the best available option for me at the time was Llama 7B construct.
Okay, and the next question is on word vectors. So do you know about word vectors and what word embedding technique that you use in your
E-
research?
Yes, I used a sentence transformer embeddings were used for that purpose, and
Okay,
a hugging face workflow was used in the background, in the back end of the structure. I do not currently remember the code I wrote, but at the time,
okay,
sentence embeddings were the perfect one because they were able to actually understand the context of the relationships defined in the UML code.
okay. And what about dataset, ma'am? Last question.
Dataset, yes, dataset. I had created a synthetic dataset. The library system was synthetically created to ensure that RAG, LLM, and MDE could go together. That was the main aim to see if they can actually work together. The future work does include that real world models we use to see if it can be converted and improved on or fine tuned on real world models.
Okay, okay, yes. Thank you. Over to you, organizers.
Yes, thank you, ma'am.
Uh,
Thank you so much for your time.
Next, I would call Aqib Hakim to present their study on enhancing password guessing efficiency, a partition-aware TCN approach beyond PGTCN.
Yeah, one second. Give me a second when I say share my screen. Okay, I hope you can see my screen.
Yes, sir.
So good afternoon, everyone. Today I'll be presenting our work titled Enhancing Password Guessing Efficiency, a partition-aware TCN approach beyond PGTCN. So this work was done by me and my team at PX University Bangalore. So to start off, passwords are still the most widely used authentication methods, but they're highly vulnerable to guessing attacks. Our goal was to improve how effectively machine learning models can generate realistic password guesses. So let me start with the motivation. Even though password-based authentication is insecure, it remains dominant. Previous works like PGTCN showed that temporal convolution networks, or TCNs, can learn password patterns effectively. However, we observed that real-world performance is not just the model architecture, but also about how data is prepared, how training is stabilized, and how generation is handled. So in our work, we propose a partition-aware training and generation pipeline using a single TCN. So it focuses only on improving efficiency and stability rather than changing the core architecture. So our results show consistent improvement in match rate, even though the changes are relatively lightweight. So before building the system, we defined a few design goals. First, we wanted to keep things a little simple, so we used a single optimized TCN instead of multiple models. Second, we focused on stable batching because unstable gradients can, hurt the training performance. And third, we aimed for high throughput inference. So we used Apache Kafka for buffering to handle large scale password generation effectively. Finally, reproducibility was important because no, the entire pipeline can run on a single workstation. So uh, yeah, so any laptop could run this. So yeah, our pipeline consists of four loosely coupled stages: data preparation, model training, password generation, and evaluation. So the key idea here is modularity. Each stage can be improved independently. The most important contribution is the partition-aware batching. This helps stabilize training without requiring complex clustering. And importantly, a single TCN is sufficient to model the entire password distribution. This slide shows the overall architecture. The pipeline flows from the password dataset ingestion to the pre-processing to training and finally generation and evaluation. A key design decision here is that generation and evaluation are decoupled using Kafka. So this allows us to scale generation throughput without modifying the core model. So let's break down the pipeline into four stages. The data pipeline, it's where we ingest password data sets, split them into training and testing sets. Then it goes under pre-processing, in which we build a character vocabulary, convert passwords into tokenized sequences. The training part, the most important, is where we use the TCN layers with techniques like gradient flipping and IDMW optimization to stabilize learning. And the last step is generation evaluation. We generate password guesses using beam search and nuclear sampling, and we evaluate them using the match rate. So the key takeaway from this slide is that each stage is optimized independently for stability and efficiency. So now coming to the technical details, the model uses sorry, the model uses 8 residual temporal blocks with exponential dilation, allowing it to capture long range dependencies in passwords. So we've created a model of hidden size of 512 with an RMW optimizer. We also incorporate focal loss with label smoothing and cosine annealing for learning rate scheduling. So this was for training. For generation, we use beam search. Beam search with nucleus sampling, and we use a larger batch sizes because it increases the efficiency. We also use an in-memory hash-based cache to remove duplicate guesses and compute match rate over the top 1 million generated passwords. So and our entire system runs on PyTorch with NVIDIA GPU support with Kafka for buffering. Yeah. So this slide shows training convergence on the MySpace dataset. So Um, Second. Yeah, so this slide shows the training convergence on the MySpace dataset. So we observed that both training and validation loss decreased steadily, with early stopping around epoch 38. Importantly, there are no uh, major oscillations, which like tell us that it's stable training, validating our partition-aware batching approach. So the general pipeline flow is that it starts from the data set which is getting pre-processed, in which it goes through the pipeline which is built for partition batching. Uh, then the training is like undergone, and then the generation and evaluation. Yeah, so compared to PGTC and baseline, our framework achieves consistent improvements in match rate, but while the improvements may seem modest, they are statistically meaningful in password guessing tasks because the amount of passwords used are massive, like in terms of millions. So even a 0.4 difference that we got in MySpace dataset is a change. So for we tested it on multiple datasets. The best ones that we got are MySpace. That was from 11.6 to 12. PHPBB from 10.8 to 11. And the Ashley Madison one, we set our own baseline of around 14%. An important insight is that the gains come from better training and pipeline design, and not in changing the model architecture that was, originally proposed in PGTC. Our ablation study confirms that partition-aware batching alone contributes a large portion of the
Excuse
improvement.
me, sir. You've crossed your
Yeah,
9 minutes. I request you to conclude your presentation.
yeah, I'm done. Yeah. To conclude, partition-aware batching improves training, stability, and match rates. Kafka buffering enables scalable generation. A single TCN model is efficient and efficient, and the most improvements come from optimization rather than architectural changes. For future work, we plan to explore adaptive partitioning, test cross-site generalization, scale to a larger model, and evaluate performance with bigger datasets. I thank you for listening to me talk. If you have any
Yes.
questions,
Akib, na? Akib.
yeah, okay, yeah.
Huh. Tell me about PGTCN. What is PGTCN? What is full form of PGTCN?
So, what is PGTS? So, PGTCN is the original baseline that we use for our model. It stands for password guessing with temporal convolutional networks.
So it's
So
data set, na? PGTCN is a data set.
no, it's a model in itself. It's a model that was
Okay.
proposed by
Existing
a
model.
previous paper. Yes, it's an existing model. So
Okay.
huh.
Huh.
So if
Tell
you're
me
asking
about it.
how, yeah, so PGTCN is a model that uses multiple temporal layers. Um, Okay, so I can explain how PGTCN is like better than brute force. That is what it's important. So in traditional brute force, the coverage is like limited by compute power, which is like low. But PGTCN, we can generate 40,000 passwords per minute because it depends on uh, it depends on the human password patterns. It learns human password patterns, unlike brute force, which is systematic. Yeah.
All right, thank you very much.
Yes, it's done from my side. Yes. Over to you.
Yes.
Hello, ma'am.
Uh, yes.
Ma'am, my name is Arjun Verma and my paper ID is 198. Actually, I just missed
joining at the starting of the session. So can you tell me about my presentation schedule? Let's say at what time should I present or should I continue this?
Sir, I will be moving according to the schedule for now, and then I will be calling your presentation again after the current schedule is done. Okay?
Okay, ma'am. Okay.
All right. Next is Sushant Maji. Sushant, sir, please present your paper on image forgery detection using convolutional autoencoder.
Yes, ma'am. Am I audible, ma'am?
Yes, sir.
Okay. Is it visible?
Yes, sir.
Okay. So, good afternoon, everyone. Thank you for the opportunity to present our work. My name is Sushant, and this is a joint work with Dr. Sachin Balkrishnan Jadhav from the School of Computer and System Sciences at Jawaharlal Nehru University, New Delhi, India. Today, I will be presenting our paper titled Image Forgery Detection using Convolutional Autoencoder. Let me walk through our approach and findings. So, here is the presentation outline. I will start with the introduction and motivation behind our work, followed by a brief background on the image forgery types, and then I will explain the literature review. After that, I will present materials and methods. Then I will cover our results and comparative analysis, and at last, we will discuss about conclusion and the future work. So, background. To see the traditional forgery detection method, they are heavily relied on handicraft features like SITF, SURF, or ORB descriptor. These methods use block-based matching with DCT coefficient or PC. However, they often struggle when post-processing operation like rotation or scaling. They have been applied to the forged region and they have limited generation capability. For motivation, the rise of deep learning gave a new direction to this field. CNN and the autoencoders have shown significantly better results in detecting manipulated image. Error level analysis, when combined with deep learning architecture, it provides discriminative features that enhance the detection accuracy. And this motivates us to develop a framework that leverages both ELA and deep learning through a conventional autoencoder. Here is the forgery types. The most common types are copy move, forgery, splicing, forgery, and removal. So in copy move, where a portion of image is duplicated and relocated to another location within the same image. And if we talk about splicing, here the elements from multiple images are merged into single image. And in removal forgery, the objects are removed and the area is filled using inpainting techniques. So in our work, we specifically focusing on detecting copy move and splicing forgery. So the problem is digital image manipulation has become increasingly accessible with the advanced editing tools like Photoshop or any AI-based tools. So forged images are now commonly circulated on social media and the internet. These fake images can be used for malicious purpose like spreading fake news, dissemination, or even evidence tampering in legal cases, any identity fraud. So this image forgery detection is very crucial across several domains, like in legal proceeding or in journalism or even in healthcare. So our solution combines a conventional autoencoder with error level analysis. The key innovation is our processing pipeline where we apply the Gaussian denoising specifically to the ELA output rather than the original image, and this preserves the forgery artifacts while reducing noise. Our model performs binary classification to determine whether an image is forged or it is authentic. So here is the literature review summary. We have studied many papers, but some of the here. So this table summarizes the major approaches used in image forgery detection. Earlier method relied on the handicraft features, like earlier I mentioned SIFT or SURF, uh, which were effective but sensitive to transformation like the rotation or compression. Later, ELA was introduced to detect compression inconsistencies in manipulated region. With the advancement of deep learning, CNN and autoencoder-based approaches significantly improved the detection accuracy. More recently, transformer-based and transfer learning approaches have further enhanced the performance. However, there will need for a lightweight hybrid architecture that effectively combine artifact-level processing with deep learning, and which motivate our proposed CAE-based framework. Here are the key contribution. We propose a novel preprocessing pipeline where Gaussian denoising is applied to the ELA output, and this is important because applying denoising to the original image could destroy the very compression artifact we are trying to detect. But denoising at the ELA output, somehow we preserve this critical for the artifact and we can reduce the irrelevant noises. We also design a convolutional autoencoder architecture with 4 encoder and decoder blocks and a classification head that enables dual task learning. The model simultaneously reconstructs images and also classifies them. Third, we use a combined loss function that balance reconstruction quality using MSC with the classification accuracy using binary cross entropy. And the fourth one is we provide comprehensive experimental evaluation on CASIA version 2 dataset, which is a benchmark dataset with competitive result. Here is the overall framework of our proposed system. So this pipeline work as follows. First, the input image is resized to 256 into 256 pixel. It then passes through ELA at quality factor 90, sorry, and the ELA output then denoise using Gaussian filter, and this preprocessed image is fed into the CA encoder, which compresses it into a 128 dimensional latent space, and then from the latent space, there are two branches. The decoder branch reconstruct the input image, and the reconstruction loss helps the model to learn meaningful representation. And at last, the classifier branch predicts whether the image is authentic or tampered. Here is some details of error level analysis. So error level analysis technique, it's what it do is it when we save a JPG image, when we receive a JPG image at a known quality level, authentic regions that have undergone the same compression history will show uniform error level. However, if there are some manipulated region in the image, so which may have been compressed at different quality levels, and it will show anomalous pattern appearing as a brighter or maybe darker regions at the ELA output. So the ELA process computes the pixel-wise difference between the original image and received version at a quality Q equals 90, and we amplify the differences by a factor alpha equals 10 to make the inconsistency more visible. So this amplified error maps is what we fed into our neural network.
Excuse me, sir.
Yes,
You have
ma'am.
crossed your 9 minutes. I request you to conclude your presentation.
Okay, ma'am. So here are the CE architecture where we have take 4 block and conventional layer 3 into 3. We use 3 into 3 kernel with stride 2 and padding 1. And here is the decoder and the classifier. Decoder also have 4 blocks, and the classifier head. Here's the description of classifier head. And here this is the combined loss function we use. And this is the training procedure and algorithm which we used where we use the RMS prop as an optimizer, and we set the learning rate 0.001 with batch size 64, and we take 300 epoch with a dropout rate 0.4. And here are the dataset details, the dataset we used, and we implement it in PyTorch framework with NVIDIA Tesla T4 GPU. And here are the summary of the hypermeters. And here are our results. So It shows the accuracy of 89.72% and with precision of 82.70, with recall 94.66 and F1 score 88.28%. And here are the confusion metrics and model loss and model accuracy over each epochs of our result on KCRV2 dataset. Here are the ROC curve and the precision recall curve of our experiment. And this is the evaluation study when we use only MAC. So these are the accuracy F1 scores and all. And when we combine both and with denoising, it is showing the accuracy better. When we use the full model like MAC plus BAC with denoising, it is the superior, means it outperform all the previous results. So we use this model, and here is the comparison with the existing model, like SURF features or SITF features or any other, and we can see that our proposed method outperform the previous model. And here is the conclusion and future work. There are some limitations, like it only do classification, not the localization, means the area where the forgery is happened. And we evaluate our experiment only on single data set. So in future we will do the cross data set validation and all. And real-time deployment is also not possible now. And here are the conclusion. So we present a novel forgery detection for combining CA and ELA, and we achieved a accuracy of 89.72 and outperformed the existing method on benchmark dataset, and it is successfully detects both the copy move as well as the splicing forgeries. And here are some future direction, like multi-scale ENA analysis or extension to video forgery or cross data evaluation. And here are the references. Thank you, sir.
Okay. So what color model you are using here?
What's up?
What color model you are using for images?
RGB, sir.
Why RGB? Yeah,
So
Sushant, why
yes,
RGB?
because sir, in our experiment, it was giving the better result. So to be honest, we didn't to apply on the grayscale image, but in future we are expecting to do it on grayscale image. But for now, we use the RGB images.
What are another color models we have? Do you know HSV?
Yes, sir.
What is that HSV? Okay,
Hello.
you are going to
Hello,
restore
hello.
the image with two. Am I audible?
Yes, sir. Yes, sir. Your question,
Ah,
sir. Sorry.
so yeah, second question is you are restoring image with 256 by 256 pixels.
Yes, sir.
Why 256 by 256?
Why to? Because sir, we have tried in our evaluation study. We have tried eh, so many methods, but 256 into 256 gives us the better result. So we stick with this.
And the last question is you mentioned Q is equals to 19 or
Q
Q19.
Q90, sir, it's a standard ELA. For ELA, we generally use Q equal to 90. So in Q equals to 90, we can means the inconsistencies do not destroyed while when we compare with the original image and ELA output. So we generally prefer to Q equals to 90.
From where you got this value? Do you have any reference or
Yes,
any
sir.
research
Yes, sir.
paper?
Yes, sir. Yes, sir. Yes, sir. I have mentioned here.
That citation is important now. So you have
Yes,
to
sir. Yes,
cite
sir.
from your
No, I cite, sir,
paper.
here. Yes, the sir, error level is 12. Sir, in reference number 12.
Mm-hmm. Okay. Okay. Yes,
Yes,
over
sir.
to you.
Okay, thank you,
Yeah,
sir. Thank you so
coordinators.
much.
Yes, thank you, sir.
Okay, thank
Next, I would call Siddharth Joshi. Siddharth, sir, are you present?
Yes, I am the co-author. Siddharth sir could not be present because of some unforeseen circumstances, so I'll be presenting the paper on his behalf.
What is your name,
Who
sir?
are
Abhishek
you? Huh?
Kukreti. Abhishek Kukreti.
Okay, Abhishek Kukreti, sir, you will present the paper Personality Rights-Based Financial Inclusion through ICT,
Yes, ma'am.
Reconceptualizing Digital Finance as a Right-Dependent Process. Okay,
Yes, ma'am.
please start.
Yes, just a sec.
Abhishek, you are from which college?
ICTIS University, sir. I
Okay,
hope my screen is
in which year
available.
you are right now?
Sir, I am a
In which
faculty
year?
over here. I'm a research scholar
Oh,
and a faculty.
okay, okay. So,
Is my screen visible?
Kriti is presenting.
Thank you.
Yes, sir.
So, good afternoon, everyone.
I'll come to know कि Abhishek is there. Abhishek Kriti is presenting.
Yes, sir. So,
Do
may
you
I
have
start?
college ID? Any college ID?
College ID.
Hmm.
Just a second, sir.
Share your college ID first.
Okay. Just a second, sir. Just a second. Just a second.
Okay, you can start your presentation later on. Share with the coordinators.
Sure, sir.
Hmm.
Okay,
Please,
sir.
please.
So, good afternoon, everyone. My presentation is titled Personality Rights Based Financial Inclusion Through Information Communication Technology, Reconceptualizing Digital Finance as a rights dependent process. Okay. So, the central theme of this particular paper is that financial inclusion should not be understood merely as an access to financial services. It must be understood as a right-dependent process because digital finance systems increasingly represent and govern individuals through data. Okay, so that is the thing. If we move on to the second slide, traditionally, what has been seen is that financial exclusion was caused by barriers such as geography of the person, poverty of that person, lack of documentation, which was massively prevalent, and the high transaction costs in the financial sectors. Now, because of the information and the communication technologies, this has changed. If I talk about things like uh, UPI, okay, so that is one example. Okay, biometric based direct benefit transfer. Okay, that is another thing. Then fintech platforms. Okay, so all of these have expanded the outreach and they have reduced the cost. Okay, but this digital inclusion also changes the nature of the how the people are included. Okay, so it is no longer about giving them the access, but it is also about the digital identity systems and automated decision making process. Like suppose there is a person who is a daily wage worker. So how is will he be perceived in the digital finance initiative? That is the thing. If I move on to the next slide, that is slide number 3. So from institutional inclusion to the algorithmic inclusion, there is a structural shift over here. Why? Because in the earlier days or in the early era, there was a access decisions were often made by human institutions through documents and personal interaction. That you went to a bank for a loan, and the bank manager would personally interact with you, scan all your documents, and then see if you're eligible for that. But in the digital age, this has become highly, replaced by automation. Now the machines, okay, or the AI software will give this judgment whether that person is fit for the loan or the financial inclusion or not. So that is the thing. Through his transaction history, his digital footprints, okay, and the AI systems basically predict ki, whether he or she is a good candidate or not. Then if we go to the next slide, so that is about alternative data and predictive profiling. Now, the fintech platforms often use alternative data such as mobile usage, geolocation, and behavioral patterns to assess creditworthiness. Ki whether, means whether that person is fit to be given the credit or not. Now, this may help include the people without formal credit history, but it also blurs the line between personal and economic life, because that now that person becomes a data. He becomes a number. He's not a person anymore. So that is the thing. Okay. As a result of this, the routine digital behavior becomes a financial signal, and the exclusion can become hidden, automated, and difficult to challenge. That if that person does not meet a certain parameter, the machine or the software will automatically reject him. Let's say his income is below the threshold which has been fed into the software, so he will automatically be disqualified, which was not the case earlier. So that is the thing. Then the concept of personality rights in the digital financial ecosystems. So what are these personality rights? Personality rights can be the mannerisms, okay, the way a person behaves in his daily life, okay, and all that. So moving further, personality rights protect the identity, dignity, autonomy, privacy, and the reputation of the individual. All these are encompassed within the personality rights. Now, in digital finance or in digital financial inclusion, these rights matter because personal data is not just collected, it becomes the basis for economic participation. Like if that person is having a certain loan in the past and he had missed a payment, so the machine might say ki this might become a behavior in the future. It might start predicting that way. So that is where his personality right can become a challenge for that particular person. So that is the thing. So the issue is not only about invading his privacy, but it is also whether the human person is reduced to a numerical risk score. Ki, based on the past data, we are assigning him a score. We are not interacting with him in a personal capacity. Right. So that is the thing. Then moving on, if we go to the next slide, which speaks about digital economic identity and structural inclusion. So our paper argues that the digital finance creates a digital economic identity based on transaction records, inferred risk, and behavioral data. How was he behaving financially in the past? If, for example, if he has a credit, so whether he was paying his credit card bills on time or not, whether he is a risk or he is safe for giving the future things like future credits or anything like that. Now that problem is that these identities can become persistent and difficult to escape. Let's say that person is facing a certain issue in his family and he is in dire need for money. Now, based on his past behavior, the system might perceive him as a financial threat. He will not be able to pay the money on. He will not be able to pay the money on time. So that is the thing, and because the process is automated, so the risk of inaccurate or biased profile cannot be ruled out. Okay, so that is the thing. So because so on these parameter on these things also a person might be rejected if false data is fed into the system. So that is the thing. Then moving on to the next slide, the right to economic self-representation. So this leads to the main contribution of our paper, that is the right to economic self-representation, which means that individuals must have meaningful control over how they are economically represented in digital financial systems. Means I should have some sort of control that my this particular data should not be shared, or how should it be shared with the financial lending authorities. So that is the thing. Okay. Then moving further, this particular thing includes the 4 dimensions, that is the right to access, okay, view and retrieve the digital financial data and economic profiles. Then the second one is the right to understand, okay, how these automated decisions are affecting the economic life. Then the person should also be given the right to contest if there is any false data being fed into the system. So he should be having the means to tell ki this particular data is false, right? So that is the thing. Okay. And the last one is provide contextual information such as hardship or informal income, that the raw data which has been fed into the system may not capture may not capture in this particular thing. So that is the thing. Then because what we are talking about here is data and the the decision on data. So whereas
Excuse me, sir.
yes,
Sorry
sir.
to
Yes,
interrupt, but you crossed 9 minutes. I request you to
yes,
conclude as
ma'am. I'm
soon as
just finishing up. Just finishing up. So the conceptual framework over here redefines the financial inclusion as right-dependent social technical process, and the information communication technology is not a neutral tool. It actively shapes how individuals are represented and classified. Okay, so that is the thing. Then if we come to slide number 9, that is talking about evaluative tests and policy implications. So what are these tests? The first one is proportionality test, whether the data collection is necessary and uh, uh, is it important to be collected. Then the second one is transparency and explainability test, whether the machine decisions by the machines are accompanied by meaningful, accessible explanations with human review available, whether the humans can review them. And the third one is dignity impact test. Do these systems treat individuals as autonomous agents? Because at the end of the day, we are humans, we are not machines. Okay, so these tests are to be done. In conclusion, the thing is that we have to use them as tools for empowerment of the people. And people cannot be uh, you know uh, identified as numbers. Okay, so that is the thing. So therefore digital finance must be reconceptualized as a rights dependent process where inclusion is measured not only by access but also by dignity, autonomy, and agency. So that was from me. Thank you very much. Any questions?
Okay, Abhishek sir, how you are going to handle the data?
Sir, data, sorry, sir, can you please elaborate your question, please?
Because the performance of your model is completely on data sets,
Yes,
if I'm not wrong. So how you are
right.
going to handle the data sets? How you are going to process? How you are going to validate?
See, the of course over here the machines are going to validate it, the data set and all that through fed in parameters, but there will be certain human element also at the end, which will make sure that the person is not excluded from the digital financial inclusion process.
Uh, Actually, I was talking about any data validation technique that you have used before processing. Have you validated the data set? Any do you know K-fold technique?
No, sir, sorry, I'm not aware about this K4 technique.
Okay, okay, no problem. Yes, over to you, coordinators.
Thank you, sir.
Thank you, ma'am.
Now, next, I would call Amrish Kumar Sharma to present his paper on privacy preservation techniques and big data sets, a comprehensive review.
Okay, good afternoon to all of you. Just I share my screen. Okay, I am Amrish Kumar Sharma as a research scholar in Oriental University, Indore, Madhya Pradesh. And my paper ID is 118, and my topic is privacy preservation techniques in big data sets. A comprehensive review. It's just a survey paper. The most important thing is that why privacy matters. Uh, At that time, the volume of data generated across the e-commerce, healthcare, banking, social networking, mobile application, and more than sectors are growing at unpredictable rate of data. Sensitive personal information often hidden within the large data sets is vulnerable to privacy attacks and unauthorized disclosure. The major sectors where risk occurred: healthcare and medical records, banking, finance, and social media platforms. Defining the privacy in the big data era, privacy is the fundamental right of an individual to control what personal data is disclosed and to regulate access through the appropriate mechanism. The term big data itself dated 1998, coined by the John Mason. The core challenges of privacy is most users accept application permissions without reading privacy policies, by mistake enabling data leakage at scale. Healthcare imperative: health records contain highly sensitive, personally identifiable information that demands non-disclosure protection. Research goal: identify among existing approaches to develop a unified, scalable, privacy maximized solution for a big data set. Here, de-identification technique. Actually, we are review or study the different type of techniques related to privacy preservation. Here, de-identification techniques: anonymity, suppression, generalization, diversity, and close. K-anonymity actually quasi-identifies are generalized, so each record is a uniformity from at least K minus one other, like zip code like 4620003 becomes 46020 hashes. Suppression: in this method, we replace the special symbols. And generalization: in this method, we generalize the value in the ranges. L diversity and P closeness extend the K anonymity by ensuring that each equivalence class contains at least L well-represented sensitive values, mitigating the homogeneity effect in income diversity across the group of regions, inferring an individual financial bracket. P closeness requires the distribution of sensitive values within any equivalence class to be within the threshold T of the overall population distribution, preventing the attribute disclosure even when L diversity is satisfied. Advanced privacy techniques are randomization, data distribution, cryptographic methods. These are the available methods. Clustering, heuristic, and optimization approaches. like clusterings, bond energy algorithm, heuristic combines the heuristic humanity optimizations method. Here we are a comparative overview of all techniques. Key trade-offs: no single technique universally dominates selection, depends on the data structure, threat model, and scalability requirements. Actually, we saw in all papers there is no mechanism or no methods are to provide 100% security. So we developed a hybrid approach and give the maximum privacy as well as data validation also. Randomization excels for large structured dataset but fails for unstructured data. Cryptographic methods offer maximum security at high computational cost. Heuristic and optimization approaches deliver high utility but are complex to implement. Multidimensional sensitivity anonymization is efficient but faces scalability constraints at large scale. Three phases of privacy preservation: pre-processing phase, storage phase, and the third one is publishing phase. Pre-processing phase actually techniques applied before the analysis like Hadoop a priori algorithm, rule mining, cryptographic methods also, machine learning methods, and storage phase fragmentation cluster-based data management ensures the sensitive attributes are segregated and protected within distributed storage architecture. And publishing phase, de-artificial generalization, hierarchies, and anonymization models are applied before the data is released to the third party or public repository. Previously, during the collection phase, there are some I have learned research papers. So FHE, HECC encryption technology, IIoT security via the federated learning, HIoT privacy concerns. So here I explain this type of method. Privacy during the storage phase, adaptive anonymity, differential privacy in ML, edge and cloud paradigm. Privacy during the publishing phase, secure map-reduce method are already exist. Cross-bucket generalization, MR monetization. Here the comparative study, privacy preservation techniques which are already exist in the world. But one most important thing is already methods which are exist, some key limitations which not provide the 100% security or more than 90%. The most problem of in all these methods, information loss. One most is the while the publishing data. Then first of information loss, generalization and suppression degrade the data quality. Scalability gaps, most techniques are failed under the real world big data volumes or distributed architecture and real time blind spot. So future research direction, differential privacy expansions, real-time data privacy, multi-party party privacy with low overhead in a high-dimensional and graph data. The case of hybrid approaches, why no single technique is sufficient? Every reviewed method from the k-anonymity to FHE addressed a subset of privacy problem. Encryption alone cannot prevent the interference attacks. Anonymization alone sacrifices utilities. Federated learning alone is vulnerable to gradient leakage. The path forward requires hybrid architecture that combines cryptographic, statistical, and decentralized techniques, governed by the quest for pervasive pressure in the policy and regulation. Conclusion: the review confirms that no existing single technique can simultaneously preserve the individual privacy and maintain full data utility in big data environments. Life cycle coverage is essential. Privacy must be enforced across the all phases. Collection, that is called pre-processing phase also, storage and publishing. not just at one point in the pipeline. Hybrid models are the future, combining encryption, anonymization, and federated learning. Within the policy complement framework offer the most promising path forward. Open problem remain real-time data release, high-dimensional privacy, and multi-party optimal budget allocation are the critical areas requiring the immediate research investment. This is the reference part. Actually, I am researching at that time, and my research is as in initial phase. So my first paper in that platform.
Okay. Sir, what is motivation behind this topic?
Sir, actually, I think privacy is the most important thing at that time, or especially for in medical field. So my research, I will align in the medical data set because in medical field, I think the sensitive diseases are so sensitive for everyone. So my motivation is,
Okay, so please comment on datasets.
sir, now at that time, I have visited many websites like Peggle, WHO website, and also I approaching some hospital. Or I think in future we will get a better data set like 5 lakh approx.
Okay, yes. Over to you, Paul.
Okay, thank you so much, sir, for giving me this opportunity.
Yes, thank you. Selvamani K. Sir, are you present now? I repeat, Selvamani, sir.
Ma'am, give me 10 minutes, ma'am.
All right, Arjun Verma.
Yes, ma'am. Am I audible?
Yes, sir. Please present your paper on bonding of material and electrical properties of EVA shoes under various physical and manufacturing conditions.
Am I audible? And my screens are moving?
Yes, sir. We can see your screen too.
Okay. Good afternoon, everyone. I am Arjun Verma, research scholar from the Department of Footwear Technology, Dalbagh Education Institute, Dalbagh, Agra. Today, I am presenting a research work titled Bonding of Material and Electrical Properties of EVA Shoes under Various Physical and Manufacturing Conditions with paper ID 198. This work is carried with the collaboration with D.K. Chaturvedi. He is my co-author. So this is the framework for today's session. We start with the abstract, then followed by introduction, the reviewing the literature, the background summary, then the manufacturing process of EVA shoes, then experiment and the analysis, followed by the results, discussion, and conclusion. So let's start with the abstract. EVA, EVA stands for ethene and vinyl acetate. It's a very versatile polymer which is widely used in so many different industries such as footwear, healthcare, electronics. It is particularly popular in footwear due to its light in weight nature, shock absorption, and insulating properties. However, with prolonged use, the cellular structure of EVA tends to degrade, which affect both the mechanical performance and the electrical insulation. So in my study, I am focusing on two major aspects. First is the bonding behavior of EVA at different manufacturing temperature, followed by the dielectric strength under varying operating condition. So in my campus, there is a facility of 100 kps HVAC system to test the various high voltage testing. So these all tests was conducted at DEI to analyze and understand the performance, durability, and the safety of EVA material. Means whether this particular material, which is EVA, can be used in from safety point of view or not. So the paper presents all the tabulated results on the dielectric strength of EVA shoes under different conditions. Additionally, it also examined the bonding properties of EVA shoes at different manufacturing temperature, which we discuss later about the different manufacturing temperature, which aiming to predict their lifespan, quality, and the finish of the final product. So if I'm talking about the introduction, as I already declare that the EVA, or which is also sometimes referred to as PEVA, which is polyethylene vinyl acetate, is a comonomer. Means we use two different types of monomer, the ethene monomer and the vinyl acetate monomer. Together they make a copolymer. So it exhibit diverse form and in structure, offering excellent water and moisture resistance, cushioning. This is the most important property, shock absorption, heat insulation, and long-term durability. So these different properties make EVA a lightweight material which is widely used in the sports footwear, including outsoles, midsoles, and different bottom components. It is also utilized as a padding due to their characteristics. EVA footwear is also suitable for electrician shoes because of its non-conductive nature. Therefore, evaluating its dielectric strength becomes essential for safety applications. Different manufacturing processes such as compression molding, here I am using the compression molding to manufacture the end product, are used to produce the EVA footwear. So here is the literature review. Totally, I've gone through total number of 16 to 17 papers to perceive whether what kind of a work is done on these particular EVA material. So in my study, I found that there is still a lack of testing, which is especially regarding to the safety point of view. So these are the so many different authors like Rahman uses the polymer composite material. So this particular affects the cost, improves the comfort, and biotip polymers improve the hygiene. Yoshihara perform the performance of EVA, how it behaves like in terms of shock absorption, totally depends on the density, the structure, and etc. Om Prakash Nautiyal explain about the shrinkage via thermal treatment and the formulation, means inside the compression molding, how the granules of EVA works at different manufacturing temperature as well as the dwell time. He also blend the different materials of EVA of different densities in the compression molding machine. So several researchers have studied that the mechanical behavior of EVA, especially its elastic nature and the shock absorption capability, these further studies highlights the EVA performs well under the compressive load, and it's suitable for footwear applications which requires comfort. Some studies also explore that the dielectric properties of polymers such as EVA, PVC, and polypropylene. So these materials shows some good insulation characteristics, making suitable for different electrical application. But none of the authors focuses on these different materials to manufacture the end product, that is the footwear. Only we main focuses on EVA, but still there are so many results are missing, like as I said, high voltage is the main reason behind whether it is suitable for safety shoe or not. So during my study, these are some identified gaps. The first is the complete replacement of the leather, which is not achieved. Long-term performance and safety need further study. Limited application in real designing, need to optimize the structural design. Focuses on electrical properties, lacks direct application to footwear performance. Experimental stage, lacks of industrial scale validation. Early stage prototypes, durability and commercialization challenges. EVA degradation over time reduces the performance, needs durability and enhancement. Structural degradation and the air cell collapse under various load or with the prolonged use, and lack of optimized formulation for long-term performance. So these are some gaps which I identify. So on the basis of that, first I'm just taking the EVA with a grade of 40 to 60. So here is the simple manufacturing process of how EVA shoes are going to be made. First, from the image, this is the end product image of EVA footwear. These are the molds, and this is the setup of a compression molding machine. So simply what we do, uh, we simply pour the granules in the mold according to the sizes. Like if we're gonna make the 6, 7, 8, or 9. So the sizes and the weight of material is totally different. What kind of a size we need to tackle? Also, on the basis of that, we just pour the raw material in the mold. Then we compress the mold, set the temperatures of both the plates. This is the upper plate and this is the lower plate. The temperature of lower plate is always greater than the upper plate, and then we set the dwell time. So once the dwell time is completed, your EVA shoe is completed. So after receiving the end product, then I just go to perform the different tests. So this is the experimental setup for high voltage testing. So if I'm talking about the sample preparation, so the specimen prepare, the size of the specimen is greater than 10 centimeter dia. Both the sides to fit the spherical electrode of 2.5 centimeter dia. A 0.5 millimeter thick material thick layer maintained between the electrodes. Then electrode position with no clearance, especially at the center. These are some test condition. The Sanitone wave voltage of frequency 50 Hertz. Initial voltage set up at the 1/3 of the test value. Then I need to increase rapidly because right now I'm using the step up transformer for my experiment, and ensures the uniform electrical stress applications.
Sir, gentle reminder that you've crossed 9
Oh,
minutes.
okay. So I am using this step up transformer. It evaluate the insulation performance and ensure that safe operation under different stresses. This is the setup for my experiment. These are 4 different categories. This is the upper portion testing, this is the bottom portion, middle portion, and the heel part. So during my once I just conduct the experiment, so these are some results. So from the table it is clear that at the manufacturing temperature of 140 degrees centigrade, the heel takes the most amount of dielectric strength, which is 42.6, as we compared from the upper portion. So heel takes the more dielectric strength, which is 42.6. If I'm talking about the manufacturing temperature of 132 degrees centigrade, the heel is 40.67 kV per mm. So this is the graph showing that heel takes more dielectric strength as compared to the upper portion. So from the result, it shows that high voltage shows different parts of EVA shoes under different voltage conditions. So upper portion has the lowest breakdown strength, that is roughly around 22 kV. Uh, these samples are manufactured at a temperature range of 132 to 140 degrees centigrade. Shoes made at lower temperature with its lower voltage, while at higher temperature leads to higher voltage. So heel is stronger while upper is the weakest region. Apart from this, I am also conducted the microscopic view with a 50x zoom. So after this, it shows that improper temperature leads to unfresh grain, while if I'm providing the proper temperature, the grains are very good. From the image, it is also clear that the first example is the case of unfresh grain, whilst the second one is the finished grain. It means proper end product. These are the microscopic views at different operating temperature conditions at 150, at 155, and 120. So the conclusion is the manufacturing temperature significantly affects the mechanical and physical properties. Optimal temperature improves the bonding, shock absorption, durability. EVA produced under optimal conditions shows better performance and longer life. Suitable for electrical insulation applications, especially safety footwear point of view. A study determines dielectric strength and safe operating voltage limit. Finished grains provide a stronger bonding and better overall performance. So, sir, basically in Agra, there is one company called Euro Safety, which totally deals with the safety footwear. So, I just proposed my idea to this particular company, and he also appreciated that. They also not tested on this particular polymer material. They simply deals with the other materials. But he also impressed that there is a scope of in EVA also regarding safety footwear. Focus remains on the polymer structure, morphology, some different thermal behavior, and the insulation properties. So these are my references for my presentation, which I'm used. So that's all from my side. Thank you.
Yeah.
If you have any question,
Yes.
so you may ask.
Thank you. Thank you. Arjun sir,
Yes.
what is main motivation behind this topic, and how
Uh,
you are going to integrating this topic with technology?
okay, sir. Uh, Actually, sir, in India, there are so many persons who are suffering from different food deformities. If you know that if I'm going to use some customized footwear for tackling these different deformity, the cost is so much. The normal people can't afford the customized footwear because the price range of customized footwear generally lies in the range of 10 to 15,000. So my main motto is how can I provide this particular solution to the person who are not so financially strong. So here in my college, I have developed the low cost customized footwear with a price range of $2 in somewhere around 150 to 200. So for this, first I just prepared this low cost customized footwear, but the testing part is still lacking. So that's why my product is ready. Now I am going for the testing. So that's why in my this particular paper, I am only focuses on whether this particular EVA product suits for safety point of view or not. That's my main motivation.
Yes, very good. Over to you, coordinators.
Yes, thank you, sir. Next, I would call Eliza Borkute to present her paper on consumer trust, security, and awareness as determinants of UPI adoption among private sector employees in Chandrapur.
Yes, ma'am.
And I request you to please be brief since we are running on a time constraint.
Yes, ma'am.
Please start, ma'am.
It's my screen visible?
Yes, we can see your second slide currently.
Can I start now?
Yes, ma'am.
So, good afternoon, everyone. My name is Eliza Burkute. Today, I am presenting consumer trust, security, and awareness as determinant of UPI adoption among private sector employees in Chandrapur. Just a second, ma'am. This study examined the factors influencing the adoption of UPI among private sector employees. The research mainly focused on three factors: consumer trust, security perception, and awareness knowledge. And data is primary collected, structure questionnaire. Digital payment have grown rapidly in India, and UPI has
Excuse me, ma'am. On which slide are you on?
introduction.
Ma'am, we can see your beginning slide, the title page. We cannot see your presentation view. Can you please try to share your presentation screen again? Or
Now, ma'am?
Ha, okay, now we can see. Please continue.
Okay. So now, introduction. Digital payment have grown rapidly in India, with UPI become a dominant platforms. UPI offer convenience, speed, and cashless transaction. So nowadays we are continuously listening. We are going in cashless. So that's why we are UPI users is increases. So however, despite its growth, many people still hesitate to use UPI due to security concern, fear of fraud, and lack of awareness. So my objectives is first to examine the influencer of consumer trust and UPI adoption. Then second is analyze the impact of security perception of UPI users. Then study the role of awareness knowledge in UPI adoption to assess the moderating effect of demographic factor on adoption behavior. So I conducted review of literature. Then previous study shows consumer trust reduces risks and increases adoption willingness to use online payment. Awareness of education improves users' confidence and users. Demographic factors such as age and education also influence the adoption of the behavior. My research built on this finding in the context of UPI users in Chandrapur. Now its scope. The scope of study include private sector employees in Chandrapur, focus on trust, security and awareness, study based on actual users' behavior. Then limitation is research limited to one district, data is self-reported and the study is cross-sectional and conducted at one point at a time. Research hypotheses are to test the objective. 5 hypotheses were developed. First is consumer trust positively influence UPI adoption. And then second is security perception increase UPI adoption and positive security perception increases. Then awareness significantly enhance an adoption. Then education level has no effect on frequency of UPI users and trust. Frequency of UPI users has no effect on consumer trust. Data analysis evaluation. Primary data was collected using questionnaire form. The data was analyzed using SPS software. Non-parametric statistical method were used because the data was ordinary in nature. The relationship between trust, security, awareness, and adoption were tested. The major finding of the studies are there is a strong positive relationship between consumer trust and UPI adoption. Security perception significantly increase users and recommendation. Awareness strongly influence frequency and continue users. Education level partially affect trust and users. Frequent users show higher trust than occasional users. To conclude, trust, security, and awareness are the most important factor influencing UPI adoption, improving user and education, and strengthening security communication can further increase uses. This study support the growing role of UPI in India digital economy. Based on the finding, the following suggestions are given. The conducted target awareness program, improve communication about the security features because many are not aware of the security features. So increase the first time users encourage the first time users, then promote organizational level UPI training initiatives. These are the references. Thank you.
Any questions, sir?
Okay. Ma'am, you are just targeting to special audience from Chandrapur. Am I
Yes, sir.
audible?
Yes, sir.
Uh,
Yes.
you are just targeting to the audience from Chandrapur. So, do you found any observations or do you have any findings of the population? Why only Chandrapur?
Because it's growing urban cities now. It's a growing city, urban city. And
Okay,
I'm
that's why
living
you
there.
selected Chandrapur. Okay. So, you please comment on the classifiers which you have used in your research.
Sorry, sir. I'm not able to understand, Kush.
Ma'am, whatever data you have taken, you are using some classifiers, no? to classify it. So you're not using any classifier?
No, I use questionnaire form, Google form.
Then how you're going to map this topic with the technical aspects?
I use for the statistical, I use SPSS for variable
What is,
findings.
what is this SVSS?
It's software. It's calculate the relationship. It's variable between two factors.
Exactly, ma'am. So how that do you have any formula how it works? How it finds the difference between or correlation between the variables? Yes, organizers.
All right. Thank you very much, ma'am.
Thank you, sir.
Next, Jitesh Kriplani, please present your paper on the impact of social media influencers on consumer preferences and purchase intentions, and empirical study.
Yes, ma'am.
Yes, ma'am.
Hello.
Hello.
Sir, your voice is not clear.
Either join from computer or mobile phone.
Hello.
Yes, sir. Your voice is echoing a lot.
Hello. Sir, may
Excuse me, sir. Sorry, I've muted you. Your voice was echoing a lot. Could you please figure out your technical issues?
Hello. Sir, I am Jitesh talking from Elisa's laptop.
Okay, now it is better. Yes.
Okay, ma'am. Ma'am, am I audible?
Yes, sir.
Ma'am, is my screen visible?
Yes, sir.
So, ma'am, good afternoon, ma'am. Today, my topic for research is the impact of social media influencers on customer preferences and the purchase intentions. So, the summary says social media influencers examines how they affect the consumer buying behavior in the digital era, and the primary data was collected from the 360 respondents from the Vadar district. I used ANOVA technique with statistical tools such as ANOVA and Perman correlations were used to analyze the data. The findings indicate a strong positive impact of influencer credibility and authenticity of consumer purchase intention. So, introduction. Social media has revolutionized modern marketing practices. Influencers and platforms like Instagram, YouTube, Facebook act as opinion leaders who shape the consumer preferences. Compared to traditional advertising, consumer today trust influencers' recommendations more. So, the key influence traits such as credibility, authenticity, and emotional engagement significantly influence the purchase decisions of the customers. Objectives. The study is guided by the four main objectives that are as follows. First, to analyze the impact of social media influencers on consumer buying behavior. Second, to study the influencer attributes like credibility and authenticity. Third, to examine the influence of demographic factors. Fourth and the last, to analyze the customer responses to influencer promotions. Review of literature. As the previous study suggests that the influencer's marketing enhances the consumer engagement and builds the brand trust, Authentic influencers positively influence brand image and purchase intention. Social media platforms play a major role in shaping our online shopping behavior. However, some studies also highlight challenges such as over commercialization and also influence fatigue, which may reduce the effectiveness. The scopes and the limitations of the study. The study focuses on influencer marketing among the consumers in the Vadar district. However, there are certain limitations that are the sample size was limited to 360 respondents. The focus was on selected demographic area and it is also based on cross-sectional data at one point of a time. The hypotheses are as follows, which are four. First hypothesis, social media influencers positively affect the purchase intentions. Second, influencer credibility perception varies with the social media usage. Third, authenticity and engagement differ based on usage frequency. Fourth, demographic factors influence consumer responses to the influencer marketings. Data analysis and evaluation. The slide presents the statistical analysis of the study. The results show a strong positive correlation between the influencers' marketing and consumer purchase intention. This means that as consumers are more exposed to the influencer content, their likelihood of purchasing the product increases significantly. Further, analysis indicates that credibility and authenticity are the key determinants of the customer trust. Customers are more influenced by the content that appears genuine rather than overly promotional. Additionally, the study shows that authentic influencer content leads to the higher engagement and such as likes, comments, share, and follows. This engagement reflects a stronger emotional connection between the customer. Another important finding is that frequent social media users tend to trust influencers more, indicating that exposure level plays a crucial role in shaping the consumer perception. Overall, this result supports the proposed hypothesis and confirms that influencers marketing has a statistically significant impact on the consumer behavior. Findings. The major findings of the study are influencer marketing significantly affects the consumer purchase behavior. Credibility and authenticity are the most important factors influencing trust and behavior of the customers. Consumers who use social media frequently show higher engagement with influencer content. Demographic factors such as income, age, gender influences the responses while age does not show a significant impact. The conclusion is as follows. To conclude, social media influencers play a powerful role in shaping the consumer purchase decisions. Credibility and authenticity are the key drivers of successful influencers marketing. Marketers should design targeted strategies based on the demographic characters. Additionally, maintaining a transparency and ethical promotion is essential to build a long-term consumer trust. Suggestions. Based on the findings, the study suggests that brands should collaborate with credible and authentic influencers. The influencer should clearly disclose sponsored content to maintain transparency. The marketers should focus on personalized campaigns to improve the effectiveness. Future research can include larger samples and different geographical regions. So these are my references.
Okay, so how you are going to collect the data?
So I have collected the data using Google form questionnaire.
Okay, so is there any data sets available?
What, sir?
Do you know any data sets? Data sets, available data sets?
So I
So
have
instead
shown you
of
on the
collecting
PPT.
data, no, instead of collecting the data from users, so there are
Okay.
data sets available on Kaggle. Do you
So
have
I
any idea about it?
so I have prepared the questionnaire, na?
Okay, so you have created your own data set.
Yes, sir. Yes, sir.
Then how you are going to validate the results? How you are going to validate the
Sir, I
responses?
use
Sir?
the social media platform SPSS.
What is that SPSS?
So it is software that helps the to define the relation between variables.
Okay, and then you are going to analyze the customer behavior.
Yes, sir.
So is it sentiment analysis?
What, sir?
Is it sentiment analysis? Okay. So show me your results. Results. Show me your results.
So can I see that?
Do we have results? These are
So
the
I have
findings you
standings.
have. Can you show me the implementation? How you're that? I just want to see the implementation.
So it
कहाँ पे
means
किया है implementation?
what kind of implementations do you want to see?
So whatever questions you have, whatever responses you are collecting, next you are going to process that responses. Yes or no? You
Yes,
are
sir.
going to process that responses. How you are processing that responses? Manually, or you are using some software?
Sir, I have used SPSS software.
Software, very good. So I want to see the results of that software, how it works. That I want to see. Are you getting my point?
That questionnaire is on different laptop and I am using different laptop, so I can't share you. Sorry, sir.
So you are presenting for the international conference. You are keeping presentation on one laptop. You are keeping results on another laptop. Do you have any? Just share your paper, research paper.
Yes, sir. I will share you in 1 minute, sir.
Are you doing PhD? Are you research scholar?
Sir, I am an MBA student.
MBA student. Okay. So
Sir, I am
next
sharing
time,
in 1 minute, sir.
yes, yes. Next time, be careful. Your paper, results, presentation should be on same laptop.
Yes, sir. Sorry, sir. Sir, I am showing in 1 minute, sir.
Yes, no problem. Take your own time.
Sir, till then, can I call the next presenter to save time?
Please, 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 please. Ma'am.
Yes, sir. Selvamani K. Selvamani, sir.
Yes, ma'am. Yes, ma'am. Yes,
Yes,
ma'am.
sir. Please present your paper on a chaos-based permutation diffusion framework for secure and efficient digital image encryption.
Is it visible, ma'am?
Yes, sir. And I request you to please keep it brief. Thank you.
Yes, ma'am. Good morning, sir and madam. My title for this presentation is Chaos-based permutation diffusion framework for secure and efficient digital image encryption. This paper was written and implemented by student Mr. Saranraj and Mrs. Kanimori, right? So I am presenting for them. So this is my outline of my presentation, which includes introduction and motivation, problem statement, literature survey, proposed work, the key generation process in chaotic and permutation and diffusion architecture, on the rest of the things with the conclusion and future work. So this is my introduction and motivation. So the explosion in digital image traffic makes image security more urgent than ever. So approximately 3.2 billion photos are uploaded daily and over 60% of the internet traffic is now visual. So the images can span critical domains, which includes medical records, satellite surveillance, social media, and military intelligence. So all of which demand robust confidentiality and as well as integrity. But however, the traditional encryption algorithms like AES, DES, and RSA were designed for text and struggle with unique characteristics of images with high pixel correlation, large data volumes, and strong redundancy. So this creates performance bottlenecks in real-time systems, which affects the cryptography with strong mechanisms. And this is the problem statement of this proposed work. So when you see the standard encryption approaches expose several vulnerabilities when applied to images, because most of the cryptographic algorithms are specified for text. So first, natural images have highly correlated adjacent pixels, and classical encryption fails to break the structure, leaving exploitable patterns. And the second is many choice-based schemes rely on low-dimensional maps susceptible to finite precision issues, limiting key spaces and brute force resistance. The third, a weak coupling between permutation and diffusion stages leaves systems vulnerable to differential and chosen plain text attacks. So finally, without image dependent key generation, it is very difficult to secure the images and transmit in the media. So this slide presents the literature survey of the work. So we have taken around some 12 to 15 papers, and we have surveyed, and we have found the research gaps for this particular proposed work. So this is the proposed framework of our work. So here, if you see, we consider into 4 integrated stages. So which begins with plain text dependent key initialization. So the SHA-256 hash of the input image is XORed with the secret key to generate unique joystick seeds. So the logistic map, which produces 4 independent key matrices. So in this permutation stage, pixel positions are rearranged using joystick indices to destroy spatial correlation. And finally, the diffusion stage applies modular arithmetic with flawless feed integration matrix, creating an avalanche effect. So the entire pipeline supports both grayscale as well as the RGB with respect to the real-time computational efficiency. So this slide shows about the chaotic key generation process with respect to the cryptographic engine, which is built around a logistic map. Right? And this generates 4 independent keys matrices from K1 through K4, each driving a distinct cryptographic operation. And this slide shows about the permutation diffusion architecture. So here this encryption operates in 2 sequential stages. In stage 1, we go for permutation, and in stage 2, we go for diffusion. In stage 1, the permutation of the Chaucer sequence generates an index array. So the pixel positions are rearranged according to sorted chaotic images indices, breaking the spatial correlation that makes images vulnerable to pattern analysis. And similarly, in diffusion, we apply the equations E equals to C times I modulo 256, where C is the circular shift integration matrix operating GF 256. So this ensures full nonlinear mixing across the image with proper feedback and other without the entire chapter. So producing a strong avalanche effect demonstrated by our NPCR metric of 99.62%. And this slide represents the color image encryption with and key sensitivity. So we have for the 3 different channels, which is called as an R channel permutation, G channel permutation, and B channel permutation. In conclusion, with respect to the joint RGB diffusion stage. So for RGB images, we apply independent permutation to each of the 3 colors. Normally, we use red, green, blue to maximize per channel scrambling. So this joint diffusion stage then eliminates cross-channel correlation leakage, making color images just as secure as a grayscale ones. So this means that even a single pixel change completely regenerates the key stream, protecting against non-plain text and chosen plain text attacks. So this research work is implemented in MATLAB, and it's not completely done. So it's just simulated with certain inputs, and we are trying to complete it early. So if you see here, we have different things. There is encryption workflow with which specifies the sequence like image acquisition, pre-processing, and second is the key generation with respect to logistic map, and third with respect to AES inspired with XOR. So this is the process what is happening in this implementation stages. And here I am not able to produce the image exactly because there is some problem in my system. So I'm not able to see the original, show the image of original image as well as the encrypted and the lossless recovery. So you will be able to see the visual output of our encryption and decryption pipeline demonstrated on the standard Lena and Craven benchmark images. And this is results which has been plotted with respect to the output of the partial implementation with respect to the histogram analysis and statistical uniformity. So this histogram analysis provides compelling statistical evidence of our encryption quality. So the original image histogram shows the characteristic non-uniform distribution of natural images with pixels clustering around mid-range intensities. So after encryption, the histogram is nearly flat with pixels frequencies uniformly distributed across all 256 gray levels. And this slide shows the exact output of the quantity evaluation demonstrating strong performance across all 5 standard security metrics, which includes the information entropy versus an ideal of 8.0 confirms negligible information leakage. So when compared to the previous work, this provides a strong encryption as well as the what you call secrecy and privacy in transmission of these images from the source to the destination. So this is the comparative analysis with respect to various algorithms that has been used in this. So the metrics chosen is entropy and the algorithm that is A is only on proposed scheme and the improvement. So the slide shows the improvement with the plus 0.39 and plus 1.19 with respect to the various parameters that has been considered. And this is a security analysis with respect to the various attacks types that has been considered for this research work. So the attacks types, if you see, you have brute force, statistical, differential attack, non-plain text, chosen plain text, and correlation attack. So these attacks has been considered, and we are tried to restrict the types of attacks with respect to this work. And the conclusion, this proposed choice-based permutation and diffusion frameworks delivers with 6 key dimensions. That is robust security with near ideal entropy with respect to NPCR and UACI metrics validated across all major attack models. And the computational efficiency through lightweight integer arithmetic and bitwise operations suitable for real-time and IoT environments. Versatile support for both grayscale and RGB images across varying resolutions. So this, when comparing with the previous things, this works. This frameworks provide some secure and scalable and practical solution for this modern cryptographic communication systems. On future work, maybe with respect to this higher dimensional geometry maps may be considered an adaptive parameter tuning. We can also use for this medical and satellite imaging because our focus on basic images which we are trying to extend in future. So these are all various possible works that can be extended with respect to the base. And these are the reference that we have taken, the sample references we have given. Thank you.
Yeah. Thank you, sir, for a nice presentation. So actually, it is very complicated to present the work of students. So I can
Yes, sir. Yes,
understand.
sir. I am not able to correlate everything properly, sir. That is the problem.
No problem. So I have one question.
Yes, sir.
Sir, what is the block size and what is the key size?
They have considered around 128 in AES, sir. 128, the key size.
Advanced, like advanced encryption standards, 128-bit block
Yes,
size
sir.
and 128-bit. So in
Yes, sir.
AES, key sizes varies 128, sometimes it is 132. So is there any technique that we are using here? You are using here. So the key size is fixed, or you are going to vary the key size with respect to the input?
We are trying, sir. We are trying to improve the key size because now the quantum mechanics, quantum cryptography, we are trying to, because 128
yes.
key size will be breakable at any moment. So we are trying to increase the key size, but exactly we are not in a position to tell exactly what may be the key size.
Okay, okay. No problem, sir. No problem.
Yes.
Thank you, sir. Thank you.
Thank you, sir.
Over
Thank
to
you.
you, coordinators.
Thank you, sir.
Yes, thank you, sir.
Thank you, ma'am. Thank you.
Now, lastly, this last paper is by Selvamani, sir, too. Sir, please present your paper on a quantum resistant security framework for real-time financial transaction systems.
Yes, sir. Again, good afternoon, sir. Is it audible, sir?
Good afternoon. Yeah, audible,
Yes,
sir.
sir.
Please
Yes,
go
sir.
ahead.
So then the next topic is a quantum resistant security framework for real-time financial transaction systems. So again, this is another paper that was written by Mr. Saran Raj. So this is the outline of the presentation. So which includes introduction, literature review, proposed framework, implementation, result analysis, and conclusion. So the introduction about this particular topic is, if you see, we have a lot of algorithms similar to RSA, ECC, AES, but all these algorithms have their own limitations. So here RSA as well as ECC is broken by Shor's algorithm, where AES is weakened by Groover's algorithm. And every day trillions of transactions are happening in the risk. So we need a quantum cryptography or post-quantum cryptography, which gives harvest now, decrypt later paradigm. So we are trying to create a post-quantum cryptography for the existing algorithm so that the harvest now, decrypt later paradigm poses an immediate risk. So this is the problem statement. So the challenge of securing financial systems against quantum threats is multidimensional. So cryptographically, RSA and ECC, the backbone of shift the payment gateways as well as the digital wallets, are provably broken by Shor's algorithm. And performance-wise, post-quantum alternatives carry larger key sizes and higher computational overhead, threatening the sub-millisecond latency requirements of high-frequency trading and real-time payment systems. So this infrastructurally, core banking systems have evolved over decades. So wholesale cryptography replacement is neither feasible nor safe. So we need to create a post-quantum cryptography resilience security mechanisms in order to protect all these things. So this is about the literature survey. We have taken around 14 to 15 papers, which helped us to find the gaps over this particular case. So the literature on this quantum resistance financial security spans several research methods. Others like Mosha, Pickrate, and Hussein, they all tried to incorporate some blockchain mechanisms in order to incorporate the security. And this is the research gaps that has been identified. So no finance specific integrated quantum resistant framework that exists, and generic PQC implementation ignores sub multisecond latency requirements, limited hardware acceleration for financial grade of PQC deployment, and so on. And this is the proposed framework as well as the architecture overview of this particular research paper. So we have 4 different layers. One is the cryptographic layer, authentication and authorization layer, transaction management layer, and audit and compliance layer. So this, with respect to these 4 integrated layers, all underpinned by FPGA and HSM hardware acceleration. So this cryptographic layer implements crystals Kyber for key encapsulation and crystals dilithium for quantum resistant digital signatures on hardware accelerated AES 256 for payload encryption. And this authentication and authorization layer provides PUF based device binding, threshold multi-party approval, and a cryptographic agility engine for seamless algorithm updates. And the third layer, transaction management layer, handles ISO 20022 message formatting with respect to FPGA, and the audit and compliance layer records all transaction metadata on a permissive distributed ledger with immediate logs aligned with to PSD2. And this is the objective of this particular research work: quantum resilience as well as performance preservation, regulatory alignment, and migration feasibility. So this framework is designed around these 4 core objectives. This quantum resilience, which is employed with respect to NIST standard, with respect to crystal Kyber for key encapsulation and crystal dilithium for digital signatures, achieving a 128-bit post-quantum security level resistance, as well as to both Shor's and Groover's algorithm. Second, in case of performance preservation, FPGA acceleration maintains a sub-millisecond transaction authorization latency, enabling deployment in high-frequency trading and real-time payment systems. And third is regulatory alignments. This framework satisfies PSD2 strong authentication. And fourth, migration feasibility is a hybrid cryptographic strategy that preserves backend compatibility with RSA ECC-based legacy infrastructures. And the cryptographic core of our framework rests on these 3 pillars, which is key encapsulation, digital signatures, and symmetric encryptions. And for key encapsulation, we use crystals Kyber, and for digital signatures, we use crystals dilithium. And symmetric encryption, AES 256 is enhanced with respect to this category. And the next slide focus on hybrid cryptographic strategy. So this cryptographic migration cannot happen in overnight. It requires carefully managed transition to maintain operational continuity. So our hybrid stages defines in 4 phases. Phase 1 is classical only RSA and ECC, and phase 2, which is nothing but a hybrid mode which combines RSA plus Kyber plus DSA plus dilithium. And phase 3 is PQC primary, which includes Kyber plus lithium. And the 4th phase is full PQC, so that is full quantum resistance. So this is a slide that represents the secure transaction workflow. So each financial transaction flows through this 6 security enforced steps. So all the data has to be processed through these 6 steps. So the raw data is formatted to ISO 20022 standard, ensuring interoperability across global payment networks. And second is Crystal Kyber derives a session key using this recipient's public key via lattice-based KEM. And third, FPGA accelerated AES 256 encrypts the payload in under 0.01 milliseconds. And fourth, crystals dilithium generates a quantum resistant signature with multi-party threshold approved enforced for high value transaction. So similarly, it has to go the entire phase of the 6 phases for the secure transaction. And this slide focuses on hardware assisted security enhancements. So the 3 hardware layers underpin the performance and security of our framework. So FPGA accelerators handle lattice-based KEM operation, symmetric encryption and key derivation, which is achieving the symmetric encryption under 0.01 milliseconds, and the PQ key encapsulation with 0.015 milliseconds per transaction. So that is reducing with respect to 18% lower power consumption compared to the various software implementation in the previous work. And this slide focuses on the audit and compliance layer. Operates asynchronously to avoid impacting transaction speed. So when the transaction completes under 0.38 milliseconds, its metadata and cryptographic hash are extracted and returned to a quantum resistance hash entry on the permission ledger. So consensus is confirmed across authorized nodes in an approximately 10 milliseconds. So these regulators and auditors can query the ledger to verify compliance without accessing transaction payloads, preserving the confidentiality. And this is an experimental setup. I think this also has not been completed completely. Around 40 to 45% they have tried to work on this particular things. So
Excuse
this experimental.
me, sir. Your 9 minutes are up. I request you to conclude, please.
Yes, ma'am. Yes, ma'am. And this slide shows the performance results with respect to the latency and throughput. So on average, transaction held with 0.38 milliseconds and 12,500 transactions per second with respect to the FPGA node. And power consumption is 18% with less when compared to the previous or other works. This shows the results of security validation that confirms the robustness across all 5 evaluation dimensions. So the lattice-based primitives provide 128-bit post-quantum security validated against both Shor's and Groover's algorithm threat models under NIST framework. This symmetric encryption quality is confirmed by NPCR exceeding 99% and UACA exceeding 33%, meeting the same threshold of our Chaos encryption work. So this is the comparative analysis with respect to various metrics: authorization latency, security level, throughput, regulatory readiness. Yes, ma'am. Yes, ma'am. So this is the conclusion about this research work and the future directions, maybe with respect to integration. Yes, sir. Thank you, sir. Thank you. Any questions, sir?
Okay, sir, here, how you are going to ensure the acid properties of what we can say the database?
Sir, a little bit loud, sir.
How we can ensure, or you are going to ensure the acid properties, atomicity, consistency,
Yes,
isolation,
sir.
and durability?
Yes, sir. Yes, sir. Actually,
Because either all transactions should be completed or not a single transaction. If there any problem, then I think these operations are taken care by acid properties.
yes, sir. Yes,
So how
sir.
you are going to ensure? How you are going to ensure the acid properties?
Uh, that we have not considered still now, sir. We have not taken into account that one. Uh,
Okay, okay,
that
no
I have to
problem,
think
sir.
it on. Yes, sir. Yes, sir.
No problem. Yes, over to you, organizers.
Pardon, sir?
No,
Hello?
no. Over to you, organizers.
Yes, sir. Yes, sir. Yes, sir.
All right. Thank you very much, sir, for your presentation.
Thank you, ma'am. Thank you. Thank you for the a member who has patiently listened all these things. Thank you. He has taken much time for listening all the papers and he has contributed here more in this. Thank you. Thank you.
So we are done with all the presentations, and I will move to the concluding remark. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters will be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Hence, kindly cooperate with the team of ICTIS 2026. I would like to thank our session chair, Dr. Chandrakant Kokane, for chairing our session. I'm sharing a token of appreciation on behalf of Team ICTIS and Global Knowledge Research Foundation and partners. Thank you for your presence, sir. And if you have any concluding remark for the presenters, please share.
Yeah, am I audible?
Yes,
Thank you
sir.
so much, ICTIS team, for inviting me as a session chair. So thank you, management of Vishwakarma Institute of Technology, Pune, for their support. Thank you, Amit Joshi sir, for your continuous support. And the paper was really nice. Some modifications are there, but no problem. Okay, definitely the authors are going to accommodate the changes. And the quality papers I found here for this track, specially. Yeah, thanks to Dimahi Patel, madam, for the nice coordination. Yeah, thank you. Over to you.
Yes, thank you very much. Now, lastly, before we leave, I request everyone to turn on your camera for a quick snapshot of this virtual conference.
Thank you, SS.
Yes, thank you, everyone. Have a great day ahead and stay safe. Thank you.
Yes, ma'am. Thank you. Thank you for your patience and coordination. And we have to thank the session chair who has given valuable feedback for all the presentations. Thank you. Thank you. And this conference provides a real framework or real platform for all the researchers to share their knowledge and experience so that they will be able to understand in which situation they are, whether they are really doing the research or they are trying to manage the research. So this type of questions will enable them to understand what the real research is. Really thankful to this ICTIS who are doing a wonderful job. Good. Thank
We
you.
appreciate it a lot, sir. Thank you.
Can we leave now?
Yes, sir, you all can leave.